All right, now it looks like we're on to sloppy reads. So I guess take this one away, Sam, and we'll make up the balance in the break here.
Okay, let's see. Someone, or yeah, there's been some interest lately in, well, as always, reducing latency on reads. So beyond the things we talked about before, there are some sort of architectural choices in Ceph that make it difficult to guarantee latency. For example, if we can't be sure that we have a proof that we've seen every write that's been committed to the client, we have to block reads until OSDs come up that let us do that. That would be the period where you're stuck in peering or inactive or down. And that's sort of a bummer. That's just a choice of the way we, of the consistency model we have. So there are use cases where it might be valid to not do that. For example, if you have a use case where every new object is created with a unique name and is never recreated and is never modified, then if you find anything with that name, you can be sure that it's the right thing. There's no possibility that you have an out-of-bit copy. So in a situation like that, it might be worth it to allow the client to read from a replica or an OSD that happens to have a copy of the PG that is not currently active for that PG. If the replica returns enoent, I don't have a copy, then the client can simply retry later on a different OSD. But if it gets a success and was actually able to read the object, then it knows it's good to go. So I guess what the discussion should be about, one, do any of you have use cases where this would be useful? Two, how do we want to make the interface hypothetically for something like this work? I think it would be for example, I do not think it makes sense to allow a client to perform this kind of read on an RBD pool because there's no way to do that correctly. I can't think of a valid reason to perform this sort of read on an RBD pool. So it seems to me that it might make sense to either make it a new pool type, which just happens to use the existing code, or a parameter on a pool that, when you set it, also disallows mutation of objects, things like that. That would be nice in that it would require the user to make a decision up front that a pool is will have immutable objects and allow sloppy reads, and it will make it difficult to misunderstand or misuse it. Any thoughts?
If you're doing copy on write from a read-only disk image, then it would be useful for RBD.
That's true, yes. Almost. Wait,
I
do you
also
guys do any...
hesitate to make a new pool type because that makes it much harder to use with existing images or existing systems.
Okay, so you're arguing that when you freeze an image to be used as a parent, you wouldn't want to move it to another pool or anything like that. That would be tedious.
Right. You don't want to, if you want to enable this optimization or something for existing pools, you'd like to be able to do that instead of having to create a new pool type. Or if you accidentally create, if you don't know about this yet and then you want to use it later, it's nice to not have to copy all your data over to a new pool to do that. But as for any feature that doesn't actually require like a data encoding movement, I would really strongly suggest not requiring a new pool type for it.
Okay. You definitely wouldn't, well, you probably wouldn't be able to do an object class in this situation. Would that make it difficult to use the parent objects?
It would be annoying, but not impossible. And for the parent pool, it actually doesn't matter. We're not using class operations there through the read, just in the clone that when we're actually doing the writing out the data. So yeah, that would be fine.
Could you make a flag? Could you make an OSD flag, like, that I'm willing to read dirty?
It would be a flag on the client op, for sure.
Yeah, so if that's the case, then you might, if the client was able to tell you, hey, I'm willing to take a potentially older dirty copy of this object, then you could make it work.
So the other dangers are exposing uncommitted writes. So we'll have to think about that a little bit. maybe just disallow reads past, what is it, last clean on disk, or last complete on disk in the log. That would probably do it. Do you guys get a lot of complaints about the copy up process taking too long? Isn't that dominated by the data movement?
Yeah, I mean, people don't generally directly complain too much. It's it most likely is dominated by the data movement rather than the read latency, right? Like the write latency is much higher because you're actually writing out the 4 megabytes, to several journals and several OSDs. But in the general read case, we're not doing copy up, doing smaller reads. I guess this isn't as important either.
And RBD is never going to recreate the same block in a different image, right?
Meaning the same exact object name? No.
Actually, if we did allow class operations, you could add a guard that said, as long as the metadata on this object indicates that it's been frozen, then it must be the correct version. Otherwise, return failure, right? But you don't actually go through all of the objects and freeze them, do you?
We're reading from a snapshot, so snapshots are by definition frozen.
Oh yeah, that's true.
That's why it's trivial for RBD. The parents over snapshots.
Okay, so that's a good point. As long as you're reading from a snapshot, you can be guaranteed that it's... Oh, unless you reuse the name. Do you ever recreate objects? So your RBD images are a sequence number and a block number, and the sequence number is never reused, right?
Right.
Okay. Okay, I hadn't thought about this for RBD. That's interesting.
And for snapshots in general, as long as you're reading from like if you're reading from any kind of snapshot, it doesn't matter if the object has been just deleted and recreated. The snapshot still either would exist or would not exist.
Mm-hmm.
There's no way to get sloppy data there.
So this would probably also be usable for RedisGW.
Yeah, that may be the case where it's perhaps more useful. Because the objects are immutable there, and they're never overridden directly.
In that case, would it make sense to add an operation that freezes an object? Snapshots would be implicitly frozen, of course.
Right. But without incurring the extra cost of having to clean them up later.
Yeah.
Yeah, that might make sense.
Oh, except hang on, if you're reading from a snapshot, so you might be... No, you'd be reading from the head object.
For RGW, yeah.
No, on RBD. Most of the blocks would be reading from the head object.
At the file store level, yes, but at the OSD level, it's still... the Rados request is still to reading from the snapshot.
The Rados request is to that, but the head object would be frozen. So that would imply... I'm trying to decide whether it's possible for you to be missing an IO that changed the state of the object before the snap, because if you're reading from head, necessarily that object on that OSD hasn't seen that snapshot yet. So you don't actually know for sure that there wasn't another snapshot that there wasn't another IO taken, or that happened between the object you're looking at and the snapshot that was requested, I think. You only know that if you've actually created a clone.
Yeah, I mean, for RBD, it's taken care of at the RBD level because it's actually fleshing out all the writes, but before you take a snapshot.
Well, that's the problem. That's why we can't tell. So if you were halfway through flushing the writes and then the acting set changed, the old replica would have an object at whatever version and would then receive a read at a particular snapshot that was in the future of its current snap context on that object. it wouldn't be able to tell the difference between that case and the case where it had fully flushed out all of the writes.
What you're saying?
That's tricky. You'd actually have to, for us to be sure, you'd actually have to go through and seal them. Would that be terrible or just not great?
I mean, in general, you also don't want to seal them for RBD because you could potentially do have people like taking snapshots and then also continuing to write the image.
I see.
You could say you're sealing this particular snapshot, perhaps, as part of doing that snapshot, but that's also not great because then you have to actually, you're increasing that, you're basically making the snapshot order n in the size of the image instead of,
That's what I meant.
eventual.
Well, yeah, actually,
yeah, we definitely don't want to make snapshots incredibly slow, which is what that would do.
well, not all snapshots, just the ones you want to be able to clone from, but I take your point.
Yeah.
That'll have to be something to think about. Let me write that down because it hadn't occurred to me before.
Yeah, so I that in the pad.
Okay. Does anyone have any other thoughts or use cases that you think would be worth capturing?
So I have a general question.
Sure.
So this would work only for replicas, right? When you're replicating. I mean, not for erasure coding.
It could be extended to work with erasure coding. And okay, so there's no inherent reason why you couldn't do this with an erasure coding pool. What you do instead is you'd pick some, like, of the OSDs you know about, you would pick some set such that it covers enough of the shards that you can do a reconstruction, and then you'd send your read messages, and assuming you got back versions that were consistent across, and you can get back a version number from the read, incidentally, if you choose to. As long as you get back version numbers that are consistent across all of the shards, then you know that you read the same version, whether it was a current version or not, from all of the copies. And then you would be able to perform a local reconstruction. But it's that last part that's the tricky part, why we don't support replica reads on erasure code pools yet. If we have a plugin system for the erasure coding libraries, and the monitors and the OSDs have the plugins locally, but clients don't necessarily. So it would be a choice to make that sort of thing available to the client, and we'd have to make some choices about how that would be configured. It might make sense to have RGW do it. It might not make sense to have librd do it, if that makes sense. Because librd is packaged with QEMU, whereas ResGW is more of a heavyweight configuration. Does that answer your question?
Yes. Yeah, thank you. And I have another kind of related one.
Sure.
Would it make sense to create a more generic consistency? I mean, to support multiple consistency levels, not just a few, and in a generic way, so you could say, okay, I want to have read my writes or have eventual consistency or strong consistency or monotonic reads and things like that instead of just.
So usually the closest people get to that is allowing you to specify the number of, or what percentage of the quorum group you need to write to. That doesn't generalize well, and it doesn't actually give you the properties that Cassandra, for example, claims it does. If you lose enough OSDs in a situation like that, you could still get an inconsistent read, even though you've read all of the full quorum group. And that's, so I guess the short answer is I have yet to see a generic system that has that much expressiveness. So the idea with this one is that we can get this relatively simply. All we really need to do is disable some checks and change the semantics a bit in Rados. It's not so bad. The next step would be to create an actual AP pool type, which does something more like what Cassandra does. That would be also an exciting project. Much more work. You'd have to rewrite, or you'd have to create an entirely new PG type. You wouldn't be able to reuse our recovery mechanisms because you wouldn't have a log, and you wouldn't be able to reuse, or the existing recovery mechanisms. You wouldn't be able to reuse the existing peering mechanisms because they wouldn't be applicable and they'd be doing things that you didn't want them to do anyway. You could probably reuse the write messages, I guess, but that's not really much of a win. I guess what I'm saying is, if you come across such a method, please send it to the list. We would find it fascinating.
Okay. I mean, there's work that it has been done by Microsoft Research, where they have this general framework where you're able to specify on a client session what's your consistency level that you want to observe, and then the system provides that for you. But I understand your point that I guess what you're saying is that there's a lot of the strong consistency semantics are kind of hard-coded in many places in Ceph. Is that what you're saying?
Well, also that, well, for instance, in Ceph with our pools, it doesn't make sense for a replica to choose weaker write semantics. It's not possible. And it's not so much because of that, it's because we have a read after write guarantee, a strongly consistent read after write guarantee. So it doesn't make sense for a client to do a write with anything less than that consistency because they can't be sure that other clients haven't requested, read after write consistency. So I guess what I'm pointing out is that even in that regime, it's probably less generic than you think it is. Although perhaps not. I haven't read that paper. Do you have a link to it by any chance that you can add to the pad?
I'll add it.
Yes, thank you.
So then going back to the sloppy reads in general, and that's the idea of like a ceiling method that would like guarantee that there were no updates. And that would make sense for RGW and perhaps other use cases where you're doing immutable objects. Just for the general like overwrite cases where you do eventually overwrite at some point, or doesn't make as much sense.
And we don't need special support for it either. All we need to be able to do is support an object class with a guard on an X header value.
Yeah.
It might make sense to add support for it simply so that there's a canonical way of doing it. And we could return a nice error if you tried to perform an override. But aside from that,
just provide a bit more safety. If people do start like using liberators more directly and aren't aware of the issues.
Yeah.
Are there any other mechanisms that you could think of that might work besides the client doing the sealing explicitly?
Well, they don't really need to do the sealing. It's just that you don't get useful results back in the Okay, so the easy one is where you create an object fully, seal it, and then never modify it. If you're actively modifying an object, the only way this kind of read makes sense is if you genuinely don't care what version you get back. That would be odd. I can't offhand think of a reason to do that, but that's probably lack of imagination on my part. So it's not so much that you need the sealing to write the code. That part doesn't matter. It's just that it seems like that would be a necessary piece for any sane human being using the interface to actually feel comfortable. Although I don't know, people seem pretty comfortable with MongoDB, so maybe I'm wrong. All right, is there anything else?
Sounds like a whole lot of nothing. Yeah.
Yep.